So tank and pump is already connected. Here we have P1, P2, P3 which stands for pressure. Then we have T1 and T2 which is tank. And also we have LS which is load sensing. Load sensing maintain a consistent pressure in the system. So we have to connect the load sensing to one of the pressure port. We have pressure relief valve. This valve is to control or limit the pressure in a system. On the valve we have port T and port P. So connect it to one of the pressure port. So this is manometer which gives you pressure reading. So connect the manometer to pressure relief valve which sends pressure to the system. And this is direction control valve. It is precisely control the flow of hydraulic fluid.
After the connection is completed, the pump was turned on. As you can see, the pressure was low. We can adjust the pressure by adjusting the pressure relief gauge. Let us set the pressure to a maximum of 50 Pascal. Okay, next, the flow control valve was fully open so that the cylinder can extend and retract. The movement of the cylinder was controlled by the lever which is called direction control valve. The speed of the cylinder can be controlled by adjusting the flow control valve. In the lab, we are required to record the time of extension and retraction of the cylinder in order to get the velocity of the cylinder. It can be calculated by dividing the time taken for the cylinder for one full motion by the length of the cylinder. The manipulated variable in this lab is the number of turns of the flow control valve. To prevent parallax error, look at the flow control valve from the same direction and turn it until you see the same number. By adjusting the resistance or opening of this valve, you can modify the rate of fluid flow to the cylinder, therefore the speed of the piston rod. Since the flow control valve increases the circuit resistance, the pump must apply a higher pressure to overcome this resistance.
In this video, I'll be talking about the piston movement based on the kinematic equation of motion. It is shown that the simple hydraulic system is constructed. Based on the previous statement, we know that the piston is directly controlled by a directional control valve that manages the direction of flow in or out of the actuator. In other terms, we can imagine the control valve as a traffic signal for the fluid going to the piston. When it's open wider, more fluid flows, making the piston move faster. When it's partially closed, less fluid goes through, slowing down the piston. We can relate this to the video in front of us. It shows that the more turns I make, the more faster the piston flows because there are more fluid going into the system. When we talk about kinematic equation of motion, we know that there are three terms: displacement, velocity, and acceleration. In this experiment, the displacement is the position of the piston, the velocity is the speed of the piston, and the acceleration is the change in speed. In simpler terms, displacement is the valve decides how far the piston moves. Velocity, opening or closing of the valve, changes how fast the piston moves. Acceleration, adjusting the valve affects how quickly the piston speeds up or slows down. So changing the valve changes how far, how fast, and how quickly the piston moves. The relationship links the valve setting and how the piston moves.